Good morning, ladies and gentlemen. This is a pass car, and inside of it we have a spring.
I see that spring.
Can you see it? Yeah. And we can compress the spring by moving in this thing. You see how it
Whoa!
changes? Okay. Oh, and it can go to different levels there. 1, 2, and 3. Ding.
Oh yeah, I see that.
So the pass car has a spring in it that can launch the car. It's got those 3 stops. Let's play.
What happens to the speed of the cart when released from each stop?
Step into my office. Okay, car goes here. And let's go ahead and actually we're gonna put it on the first stop, right there. It's got 2 stops left.
Here, let me go get this for you.
Oh yeah. Oh, and then I need to get my board, huh? We were so prepared.
What board? No, this is all
yeah.
you need.
Oh, yeah, to push the thing down. I was thinking about writing this thing down, but we're not collecting data. Forgot. Okay, so the question was, what happens to the speed of the car when released from each stop?
So here's the first stop.
First stop.
Well, that was weak.
Well, not very exciting. Okay. And we come back here. So first stop, and now second stop. There we go. And
Oh, that mo better.
oh, hey, think.
That mo better.
We're better. That's right. Okay.
And the third stop.
1, 2, 3.
Uh-oh. Stand back.
Okay, well, what was the difference between the first and the second one?
Second one was faster.
Okay, what's gonna happen this time? Wait, oh!
Damn!
It almost derailed. Okay.
Well, the farther you put the spring in,
The further I put this in, the faster it went, right?
yeah, because you're
On the track.
squeezing the spring more.
And so, is work being done pushing in the spring?
What is work?
Well, work is force times displacement, and I'm adding a force.
Yeah.
Is it going a displacement?
Yes, it is.
It sure is. So am I doing work?
Yes, you are.
Yes, I am. What happens to the work done?
Ooh, that's a good question.
So I'm doing work on this.
Well, you're putting the work in. How did you get the work back out of it?
Well, I push this button right. Oh!
Oh!
So what's happening to my spring right here?
That's an excellent question.
Well, the spring is becoming more compressed. So what happens to the work done? Well, it's stored in the spring. And that brings us to work changes energy. Okay, oh, we just did that. Oh yeah, there we go. Work changes energy, and this is our work energy theorem. What do I mean by this? Work changes energy.
Well, you got it in words, you got it in an equation. It's
Yeah.
so both the same thing.
Double trouble. And positive work increases energy. Negative work decreases energy. Let's look at an example. The infamous cash money, baby.
Cash money.
Okay, so you have money.
Got some
You
money.
get some more money.
That's positive cash flow.
Positive cash flow. And after you have
Lots more money.
lots more money. Now, same amount of money. This time, negative cash flow.
Well, you got to spend that money on something. What good is that money in the first place?
And afterwards, you have less money. Well, you have this much money,
Yeah.
right? And so the same thing applies here with our work. Positive work increases energy. Negative work decreases energy, just like our cash. Money flow, baby. Okay. Mechanical energy. So there's lots of different types of energy. We are going to confine ourselves to working with mechanical energy to keep our life simple. This is the form of energy due to the position, potential, or the movement of mass, kinetic. So when we talk about mechanical energy, we're talking about potential energy and kinetic energy.
Okay.
Those are the 2 types. Potential energy. Potential energy stored in a spring, and U stands for potential energy.
I don't know whose idea that was.
Doesn't make much sense.
It don't make
right?
no sense to me.
So energy, potential energy, stored in a spring is represented by this equation: 1/2 K delta X squared.
Yeah.
Anything else about that? Nah. Okay. And then kinetic energy varies with the mass and the velocity. So our kinetic energy, this one makes more sense, K, 1/2 mv squared.
Yep.
And then we've got this thing. Work is equal to change in kinetic energy.
Work done changes the kinetic energy.
So
Yep.
work, force time distance, delta K, okay, all these different things. The important thing is write these equations down. We're going to be using them in the future. And then last but not least,
It's an explanation.
this is an explanation. So work is the change in kinetic energy. And whenever we're talking about the change in something, we're doing final minus initial, or the change in kinetic energy equals 1/2 m times the change in velocity squared.
It's the velocity that changes when kinetic energy changes.
Not the mass, we're looking at the velocity here. Just like we noticed on the cart,
That's right.
right? Okay, for homework, page 166, 14, 15, and 17. Go get them.